This recording is for the review questions at the end of Chapter 4, Chemistry. So those are the review questions in the textbook on page 124 and 125. And I won't be doing all the questions, I'll just be doing the ones that are basically problems. So we're going to start with number 11. And number 11 says, give the ground state electron configuration for the following elements. And the first one is nitrogen. So if you look at the periodic chart for nitrogen, it has 7 protons, and therefore it has 7 electrons. So if we do the electron configuration for that, it would be 1s2, 2s2, and then 2p3. That gives us the 7, it places the 7 valence electrons. Okay, then the next one is aluminum. And if we look at aluminum, it's number 13 on the periodic chart, so it has 13 protons and 13 electrons. So 1s2, 2s2, 2p6, 3s2, and then 3p, aluminum is the first p. So that adds up to the 13 electrons. Okay, next is magnesium. Let's go ahead and erase these. Okay, so magnesium's on the periodic chart is number 12. So it has 12 protons, therefore it has 12 electrons. So we start with 1s2, 2s2, and then 2p6, and then we go 3s2, and that's it then. That adds up to the 12 electrons. And then the last one for number 11 is bromine. Abbreviated Br. And looking on the periodic chart, bromine is number 35. So it has 35 protons, therefore it has 35 electrons. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6. Then we go to row 4, 4s2, and now we're in the D's, but D, we brought back an energy level, so it'd be 3d10, and then we go to the 4p, and then bromine is 5 within the p. So that's the electron configuration for bromine. Okay, then we are asked to do the abbreviated electron configuration for iodine. Okay, so iodine is I, and On the periodic chart, iodine is number 53. So for the abbreviated electron configuration, we're going to find the 8A, the element that is in column 8A that is above iodine, and that's going to be Kr. So we put the Kr in brackets, and then we start the electron configuration from that point. So then we would, it's 5s2, and then we're in the Ds, so it would be 4d10. Then we go back to the energy level 5 for the Ps. So 5p, and we're 5 over. So we have 5p5. So that would be the abbreviated electron configuration for iodine. Okay, number 13, we're given 3 electron configurations and we are asked what is wrong with each one. Okay, so this is the first one. And what is wrong with it is right here, because you can't go on to a higher energy level. Here we went on to 3 when 4 was not fully filled. So this would need to be filled up with 6 electrons before you could go on to the next energy level. And then B is this electron configuration. Okay, so looking at this, in row 3 does not have a D level. So this would be incorrect here. And the 3D level actually would go in between these two. So that should be moved there. And then the next one is 1s2, 2s4, 2p6, and 3s2. So the error on this one is right here because the s level can only hold 2 electrons. So the biggest that number can be is 2. It cannot be a 4. Okay, number 14 gives us an electron configuration. We're asked to say what element it is. So here's the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, and 4p2. Okay, so if we add up the electrons, we get 10, 11, 12, 13, 14, 28, 29, 30, 30. So the electrons add up to 32. So if we look at the periodic chart, the element that has 32 protons and therefore 32 electrons is abbreviated GE, which stands for germanium. And again, this we would put this 3D10 over there if we were. I'm not sure why they wrote it like that. That's not typically the way that it's done. Okay, number 15 says, what do we call the elements in group 8A on the periodic table of the elements? Okay, so those are called what? They are called the noble gases. So all the elements in column group or group 8A are called the noble gases. And we discussed in class how the noble gases would all, because they're in the same column, they are going to have similar chemistry. Okay, number 16. Which of the following elements should have very similar chemical behavior? Okay, so we are given calcium, selenium, aluminum, Pb, which is lead, and In, which is indium. Okay, so the ones that would have similar chemistry would be the ones that are in the same columns. So calcium is not listed with any of these others. Selenium is in group 6A, and also in 6A, there are no others in 6A that are listed here. Aluminum is in group 3A, and also in group 3A is In or indium. Okay, so because these two are in group 3A, they are going to have similar chemistry, and Pb is in group 4A, so it's not with any of the others. So those two would be the two that would have similar chemistry. Okay, number 17 asks us to draw the Lewis structure for oxygen. Okay, so remember Lewis structures, picture the number of valence electrons. So oxygen is in group 6A, which means that it has 6 valence electrons. So we would draw it like this. Okay, so there are 6 valence electrons for oxygen. Okay, number 18 says draw the Lewis structure for the ion that oxygen forms in ionic compounds. So oxygen, we just said has 6 valence electrons, and it's in group 6A. So it would desire to have 8 valence electrons. So to do that, so I'll change the color here. It would gain 2 electrons. Okay, so if it gains 2 electrons, it's then going to have 2 So oxygen has, it's number 8 on the periodic chart. So as an element, it has 8 protons and 8 electrons. If it gains 2 electrons, now it's going to have 10 electrons. So its charge would be -2, or 2 negative. And because it's a non-metal, when it becomes an ion, we add the ending "ide," so it would be oxide. Okay, number 19 says draw the Lewis structure for the ion that potassium forms in ionic compounds. So the abbreviation for potassium is K, and it is in group 1A. So it has just 1 valence electron. So this would be its